Assalamualaikum and good evening. My name is Nuatika binti Muhammad. Today, me and my partner Muhammad Qayyum will be explaining a bit about the Lab 5, which is the voltage regulator. So, I'll be doing part 1. So, part 1, we are asked to construct an op-amp series voltage regulator. As you can see here, this is the circuit constructed in the multisim software. So the op-amp is used to compare the obtained voltage output and the voltage generated by the Zener diode. We were asked to run the simulation on the circuit constructed and recorded the data of voltage across the R4 and the voltage across the Zener diode as we increase the value of the voltage source from 1 volt to 15 volt with an increment of 0.5 volt. From the tabulated data, here, we were asked to calculate the voltage across R4, or known as resistor load, when the Zener diode has reached the Zener voltage point. That is when the voltage across the Zener diode becomes stable. As you can see here, the Zener voltage goes low at 5 volt. So we're assuming that the Zener voltage is at 5.1 volt. So calculation has been done up here, and it is observed that the final output voltage Vout is near the value recorded in the table. Here 7.65 volt, and the final is 7.616 volt. Next, we move to the part 2. So, in part 2, we were asked to construct a full bridge voltage regulator circuit. We were asked to identify which is the full bridge rectifier circuit. So here we have identified this is the full bridge rectifier circuit, which contain only the rectifier and the resistor, and this is the output. Output of the rectifier should be half wave of the input and all be positive value. Next is to identify the voltage smoothing filter, which is the capacitor. Capacitor is used as voltage smoothing filter. So here you can see the ripple where the half wave has been filtered to be a ripple voltage waveform. Next is full bridge rectifier circuit with voltage smoothing filter, which is the capacitor, and the voltage regulator circuit. So here we are measuring the waveform at the after rectifier with smoothing circuit and the output of the voltage regulator. So here you can see the output of the voltage regulator is almost to become a straight line. So here you can see, we can refer that after the IC regulator, we should get a straight DC line. So next we are replacing the smoothing filter capacitor with a bigger value, which is 220 microfarad at the input of the voltage regulator here. Then we could see that the output of the voltage regulator here will produce a really smooth straight DC line. So from here we can conclude that a bigger capacitor value is needed in order to have a good performance for a full bridge voltage regulator. That's all for me. Next we continue with Qayyum.
Assalamualaikum, my name is Muhammad Qayyum, and today we'll talk about part 3. In part 3, we were asked to construct an adjustable voltage regulator circuit. We were asked to measure the value of R3, VR3, and VR2. But first, we need to set VR3 to 5 volt and measure the R1. So, here's our circuit. As you can see, we get 5 volt and 161.159 ohm. So and then we get the results and put in the table. So here are the results: VR1 5 volt, R3 161.15 ohm, VR3 1.612 microvolt, and VR2 5 volt. So as the voltage increases for VR1, the resistance in R3 also increases. For same goes to VR3, but in VR2 it keeps constant until VR1 hit 7.5 volt. It decreases 4.158. For max rotation we get 7.555 volt. VR3 we get 5.766 volt, and VR2 keep on decreasing 1.789 volt. Thank you.